Software architecture, design patterns and principles, and all-around IT put into one podcast.
The goal is simple, to give you even more from DevMentors.
My name is Peter.
My name is Derek.
And let's discuss the software as we know it.
Welcome to the second episode of our new podcast called Software as We Know It, or Software as We Know IT. And today, as we have announced in the episode number 1, we start the regular formula of this podcast, which is not only Peter and myself, but we also talk to a great expert from our industry. And today's topic is honestly one of the most frequently asked by our great community, especially under my CQRS mini course. So today we finally discuss event sourcing with our great guest, Oskar Dudycz. And during this episode, you will hear what is the event sourcing, how to properly design the stream of events, why Kafka may not be the best option for this technique, what are the common mistakes and the pitfalls, and why you should definitely not call your ex while being drunk. So I hope you'll enjoy this episode, and let's just get into it. Our today's guest is Oskar Dudycz. I must say that when I hear the term event sourcing, you are one of the first names that basically come to my mind. But probably there's a chance that some of our listeners don't recognize you as an expert and as a software engineer. So maybe you could just tell a few words about yourself.
So I'm not precisely sure myself if I'm treating myself as an expert. I would think about myself still more like a practitioner, but I appreciate the kind words. So my name is Oskar Dudycz, and I'm still thinking about myself about developer, although my current title is a bit more enigmatic. I'm working as a developer advocate at Event Store. And I started my career over 14 years ago, and I went through the whole journey like apprentice, developer, technical leader, team leader, project manager, but I'm still trying to be as close as possible to development. And about my experience with event sourcing, so it started the same way as typically, I think it's starting. So I was working on a financial module, and my colleague said that sounds like a good matching for event sourcing. And I started to use at first Marten framework. So I was a user. Then I started to work more and more and contribute. And right now, besides working at Event Store, I'm also a co-maintainer of the Marten framework, which is also allows to use event sourcing and store events in Postgres database. So my journey started about I think 5 or 6 years ago, and right now I'm trying to share my journey, share what I learned, and that's one of the key things that I'm doing at Event Store. So I'm trying to persuade that event sourcing is not so scary as it sounds, and that Event Store can help in building applications closest to business.
Okay, thanks. So to all our listeners, if you have ever worked with event sourcing, there's a high chance that you have worked also using the Oskar's code, whether this was Marten or Event Store DB.
I mean, you don't need to be that humble to be honest. I mean, if you are the advocate for the event store and you are maintaining and you are one of them, I would say, most active contributors for the Marten, then I would definitely consider yourself as an expert in this matter.
Exactly.
So you don't need to be that humble, I guess.
Yeah. So let's talk about the event sourcing, because this is going to be the main topic, but probably not only of today's talk. So how would you describe the event sourcing? What does it mean to you? What do you think it is?
So maybe I will start with explaining what event sourcing name means, because I think that's a key thing to understanding what event sourcing is. So it means that in event sourcing, events are the source of truth. So what that means is that event sourcing can be pictured from two perspectives. The first one is the simplified one. So we are storing, after each business operation, we are storing a fact, so a result of our business operation, as an event. So event gathers some specific business information like shopping cart confirmed, tentative reservation created, invoice issued, or whatever. But it's also a technical message or technical, just a payload that we can store in a database. So in this case, event stores. And then we are also retrieving states from the events. So event sourcing can be pictured as a simple storage pattern. So we are storing event and then getting events from database and building the state from them. But for me, the even more important aspect is that by joining those two perspectives, so technical and the business one, we are getting a better understanding of the business process, because we can think about events as a checkpoint. Like each event can be a checkpoint of the business workflow, of the business process. So let's think about the reservation process. So at first we are creating tentative reservation, then we are maybe changing the type of the room, so from the single to double or king. Then we are having further negotiations, and after that we are confirming reservation, then the invoice is issued. So each of that is a fact and something that has happened for the specific business object. And if we are talking about the events, then we can share the common understanding between technicals, so as developers, and the business people, because business people understand that even better than us, because they are thinking like about the processes, about the checkpoints, etc. So for me, event sourcing, besides this technical part, the most important is that it helps to join understanding and bring the business and knowledge directly into the code, technical and infrastructure. Because if we are storing those events or sending, so integrating our services with events, then they are both technical things, so messages, etc., but they also gather a specific business knowledge.
So to me, what you've just said is that now, just to be clear, instead of having one, let's say, this reservation object in my database, which is effectively being modified over the time, I'm now storing the stream of, some sort of set of the events within my persistence layer. So I could clearly see at a certain point of time what actually happened within my reservation, right? It's not like I'm seeing only the current state, but it's more like the whole sequence of the events that led to the current state through the time.
Yes, that's correct. So one of the biggest advantages of event sourcing is that in event sourcing, no data is lost. And we can say that, yeah, but in the regular databases, we are also not losing data because those databases are meant and created to be durable, right? Mm-hmm. But if we are overriding in the typical approach, the classical approach, if we are changing state, then we are storing new state so updating, for example, a record in the relational database or updating the document in the document database. And after that, after we override this data, then we don't have the previous information. We are losing the business context. And in that regards, the classical approach loses data. And nowadays, storage is relatively cheap. And it shouldn't be a huge issue to just store more information. So the storage is cheap, but information is priceless, especially that we have a lot of solutions like analytics, etc. And also the critical part of understanding event sourcing is that not only we are storing those events and in a thing called event streams. So event stream is like all of the facts that were registered for specific objects. So for example, all the facts that we registered for specific operation, but that's also we are retrieving the state from those events. That's the only way to keep events as the source of truth, because that's really important, because I think maybe even majority of articles or talks that can be found on internet, event sourcing is quite often confused with event streaming. And event streaming, like using Kafka as event source or other messaging platform like Pulsar, etc. The name sounds similar. So event sourcing and event streaming. And in both ways, we are storing or publishing events after each business operation. But the difference is with the details. So in event streaming, it's more about messaging. So we are integrating different services with each other. So we are using events as a way to pass information, like, for example, reservation was confirmed, then the reservation module informs other modules, like, for example, financial module, that, yeah, see, I finished my job, you can take it from there. And in events sourcing, it's more about durability and recording the business operations and then building from that. So event streaming is more about messaging, so talking with each other. And event sourcing is more about being sure that what has happened we have stored and we can retrieve it, and then we can know everything and all the context of what has happened.
That's to me, this is quite interesting point, because as you also mentioned, there were quite a lot of articles saying that, okay, this is how you can make the event sourcing with Kafka or something. And to me, that was also some sort of weird thing to do, because, of course, I mean, conceptually, in here and in there, you might have the events, and of course, the Kafka, let's say, allows you to partition the data and store it. But the Kafka's main capability is still, as you mentioned, the messaging itself rather than the persistence. So I would not consider Kafka as a database, right? Or the place to which I would like to write my information, because effectively, if something happens and or maybe I'm storing this for a much longer time than I would like to, then probably for the whole sufficient of the Kafka performance, I would like to simply remove this old unused data. And to me, doing this on the event store is something that potentially I would like to avoid, simply because I'm losing the data, the information, which, as you mentioned, is priceless, right?
Mm-hmm. Yeah, so just before I go further, I would like to say that I really like Kafka, and I worked successfully with Kafka in my past project, so it's a great tool. But I just think that it's not a great tool for event sourcing. So, of course, the same, what I will tell in a second, applies the same for other streaming platforms, but of course, Kafka is the easiest target because that's the most popular one. So that's just short disclaimer. But I think that a lot of people that are, after reading those articles, that they could use a streaming platform as for event sourcing, they are getting into the troubles because when you are starting and you are not sure what you would like to choose, then probably you would like to choose the tool that is quite popular and mature, and that's the first thing. Then when you start reading, then you are also reading those articles that are created for this specific tool. And if we try to use event streaming platform as a database, because event stores are in fact the set of databases, and that's how they should be treated, as you said, then there are a few things that streaming platforms just cannot do. So they don't handle optimistic concurrency, which is quite critical, because if you don't have this option, then it's hard to be sure that you are making decision based on the current state. So event stores like Event Store DB, Marten, SQL Stream Store, and other stores that I know are supporting strong consistency on writes. So in Event Store DB, the appends are atomic and then more or less like a serializable transaction level on regular databases. On Marten, we have Postgres underneath, so obviously we can do the same transaction levels. On Kafka, for example, there is no optimistic concurrency. So you cannot know that someone in the meantime didn't produce another event. Like, for example, you confirmed reservation and then someone decides that that would like to change the room type. But the rule is that you cannot change the room type after you confirmed reservation. So in Kafka and streaming platforms, you don't have this option. You like the first wins, right? So you can producer just publish and that's all. What's more, those streaming platforms don't provide option to read from stream. And in those articles, it's like, yeah, you cannot read, but you can subscribe to it, which is not precisely the case the same way, because for reads, one of the key features of databases is that you can read your own writes. It's one of the basic promises of databases. A lot of, not all, but a lot of. So that's something that people would typically expect. So if you appended something, then you could, right after that, you can read and get all the data that you just stored. For the streaming platform, that's not possible. Even if we think that and provide some syntactic sugar on top of subscribing to change stream, then you have always eventual consistency. Some queues even don't provide the ordering guarantees, which is also quite critical because if we are thinking about event sourcing, then as I mentioned, we can simplify that to storage pattern. So if it's mostly about the write model concept. And if in the write model, you expect to have much stronger guarantees than for the read models. So you would like to know, for example, whether one thing happened before another or after one, because that might be quite crucial for the business logic. Let's say if you try to withdraw money from the account, then it's critical to know whether you had this money there, right? And in streaming platforms, you don't even have this API to know that. So you can just publish event, then subscribe. And that has a big implications. Of course, there are patterns that can try to somehow work around these consistency issues and consistency guarantees, but still they are workarounds, not, as you said, not a natively built features, which is quite critical. Yeah. And for event stores, they are more focused on making sure that you are storing events, that you can make a business decision based on the current state, not just have the eventual consistency on writes.
Yeah, to me, this is the key conclusion from this is what you just said, is that natively some things which of course can be done on the, let's say, some messaging level are more like workarounds rather than the native capability. And especially what you mentioned about the ordering, because someone may say, okay, yeah, but we have the partitions on the Kafka, and actually I might have the partial ordering regarding my partition, which is true, but also quite a lot actually depends on what key will you use for the partitioning, and that's where it actually starts being a little bit more tricky, because for the data store, it's obvious that I can read my all writes and just get the whole stream of the data from it, while on the message on the messaging level, it's rather whether my topology fits and will be as close as possible to what you would like to achieve. So it's good that you mentioned that difference between the Kafka and using Kafka as an event store.
Yeah, it's I see where this confusion comes from, because unfortunately the resources around event sourcing are quite a lot time confusing, and also those tools are doing similar things. Like majority of event stores that I know can also have the publish subscribe semantic, so you can subscribe to the change stream, so the events that you are appending to the stores. So technically you could even use those event stores as a also messaging platform, but then I should have another rant why you should not be using those as a messaging platforms, because they were also not built for that. So I would suggest to use the right tool for the right job.
Yeah, which, as we know, is not always the case in the IT industry. Sometimes we have a tool and we are just looking where to apply it, where to use it, not the other way around. So actually, I have one question about the, let's say, typical use cases for the event sourcing, because quite often I would see a case like a bank account where you might, let's say, receive or send some money transfer. So let's just assume that maybe every day you might receive or send a few money transfer to other bank accounts. And then, for example, over a period of year, it might be easily, let's say, few thousands of transfers in total. So would you say this would be, for example, a good use case to keep those as events? Or would you say we should look for kind of, let's say, business models on top of which we could have much shorter streams of our events?
So I even wrote a blog post that is titled that bank account is not great example of event sourcing. I mean, it looks right, because for the basic introduction, that's precisely the case. As I mentioned, I also was starting with the financial model, because the accounting works like event sourcing. So each operation is stored one after another into the accounting books, and so those information have the precise timestamp, precise order, specific information. So for example, where did you withdraw money, whether that was ATM or maybe cash in the bank, etc., or where did you send your money, when did you transfer it. But as you said, this example quite quickly raises hard questions that are not so easy to answer precisely without saying, like a consultant, it depends. Because, like you said, it would be counterintuitive, to say mildly, to say that, yeah, it's fine to load 20,000 of events to retrieve the state. Maybe let's stop for now how to make, because I think that I didn't explain how this retrieving state from event sourcing works. So the only thing that differs event sourcing from other storage patterns is that we are getting a set of events. So all the facts that were recorded for the specific thing, like a bank account, so for example, or transaction, then we order them in the order of appearance and apply one by one. So if we have bank account, then if we withdraw money, then we need to decrement our current balance. If we got money, then we need to increment it. So that's the simplest way. For example, if we have reservation, then if we created reservation, then we set the basic data like a guest information, set reservation ID, etc. If we change status to confirmed, then we are just changing the reservation status to confirmed, and that's all. If we are changing room type, then the event room type change will only gather specific information about that type of change. So, for example, new room type. And when we are applying one by one, then we are updating only this subset of the whole state information. So we are just building current state from the events one after another. So getting back to our 20,000 of events, if we have the for each, then maybe it wouldn't be so hard in all cases, because events are usually quite granular, so they shouldn't have at least a lot of data. But still, it's undeniable that it will be always slower to get 20,000 of records than getting one, as in the regular approach. So for this case, that's one of the important difference of modeling in the event sourcing systems. So we need to think about the temporal aspect of our entity or aggregate. So for example, if we think about account, then in accounting, we have something that is the process that is named closing the books. So if it's accounting for our company, then each month we are making summary, and each month we can close these books for the specific month and focus on the next month, because the previous month is typically just unchangeable. If we would like to change it, then we need to send another summary, etc. We are just appending new event, that's why I'm also saying that it's quite aligned with the event sourcing vision. So for the bank account, it's similar. If nowadays it's not the case, but I think that even a few years ago, if you would like to get the previous transactions from older transactions, then you probably would need to use different form in the UI, or you would need to request so they would send you like those really old transactions. So in the same way, we could deal that with the event sourcing, because typically we could split the lifetime of our entity to the currently working set. So all the information that we need to make our business decision, and the older one that we could potentially archive. So let's take another example. If we would model the cash register in some department store, then we probably wouldn't like to keep all the transactions that happen for whole cash register, because again, we would get like 20,000 of events or even more for each transaction that was registered. But if we ask our business about the temporal aspect, then it appears that business don't work like that. Typically, in business, all of the things have their own life cycles. So for example, in cashier, we have cashier shifts, and we don't care on the operation side of things what happened on the previous cashier shifts. Like the current cashier is probably just interested on the cash amount that they got from after the previous shift, and maybe some summary. So we could, in theory, if we add this aspect and add this lifetime, and for example, not have our stream of events for the whole cash register, but for cashier shift, then it might appear that instead of having like huge set of events, then just getting like 100 or 20 or 10, or for example, another business domain like a patient management, we don't need to keep all the visits for the patient or for whole clinic. We can split it per day, etc. So that's important modeling aspect. And so I would suggest to discuss with business and ask them a lot of whys, because from my experience, usually business domain have those life cycles. But for our domain expert, those life cycles are so obvious that they sometimes don't mention that to them, but to us. But if we ask enough, then typically we would get that one.
Yeah, that's really, I would say, really important line, especially that, as you mentioned, there's in many cases this is just obvious for the business, but when we even speak about the domain-driven design and let's say boundaries around the business rules and the invariants that we need to protect, let's say within an aggregate, in many cases, those rules needs to be protected, but only within some chosen period of time. And this also could be used as a heuristic for narrowing down the boundaries of our aggregates, which make them also basically shortens their lifetime and allows us to be more flexible on the model level. And I wanted to ask a question regarding, because you mentioned one very interesting thing, because the time aspect is of course one thing. So keeping the streams as short in terms of lifetime as possible. And the other thing that you also mentioned is that that typically the events, you need to keep them small in terms of the payload or the information that they they have. So they are very granular, which I believe that this is quite an advantage when it comes to I would say typical approach in which you have like reservation updated, and then you have events. The whole event being the whole, let's say, aggregate being put into the event, which of course may produce even if you're not event driven, such operation is very maybe not very, but it's likely to have some negative consequences, like false update on the or write skew on the databases. And the advantage of that the events actually forces on you is that because the change is portioned and is very granular, those collisions on the data level are, I would say, maybe not completely removed, but it's now very unlikely to happen, because if I'm not putting all of my data regarding the aggregate into database, then theoretically I should be safer in this case. And of course the time aspects also helps in this case. But the thing I wanted to ask is that whether this is what you just described, so the time aspect plus making the events granular, isn't just the answer for the very, very common question regarding the event sourcing. So what about the maintainability of the solution? Because after all, as a developer, we all know how this works, right? We know that the business likes changes. So I thought about event having properties X, Y, and Z, and all of a sudden I need to add or remove some of them. So a lot of people are worried about versioning the events. So the question is whether this is isn't this just the part of the solution?
Yeah, so I would say that the best way to handle schema versioning is to try to avoid the need of doing it. And short living streams are some potential recipe for that. Maybe I will give an example from the domain-dependent event sourcing. In my previous company, we had a supporting ticketing system, and that was quite old system. Legacy, name it legacy, is it should be named rather like a legacy, but it worked, and we had one quite big client still using it as a major supporting ticketing system. But it was really hard for us to even maintain it because almost no one knew how it was working precisely. So not surprisingly, we suggest our client that we would like to rewrite it. And we even came up with some POC, and we spent a few days discussing how we could run the migration to make it as seamless as possible for our client. And it appeared that when we came to the client with the final proposal and different option for the migration, then client said, like, I don't need this migration. Why would you want to do the migration? And we were like, what? And I said, like, we don't care about the old data. This is supporting system. The data lives like a 1 day or 2, and we don't care about that. So just make it possible to switch the system to use the new one from the another day. Just migrate the open tickets and call it a day. If we want to have a look on the older data, then we will just open the old system, in a read-only mode and don't care about that. So in precisely the same way, we could think about limiting need for versioning, because each change can be done in a non-breaking manner. So for example, if we adding new field to event, then usually it's not a breaking change unless it's critical for the business flow. Like, for example, we forget about the reservation status. That's quite important. So if we add it, then typically that means that it's some breaking change, even though technically it's not. But if we are renaming, for example, then we could do it like to keep the old name and the new name for some period. Or we may somehow, for example, publish events in the old format and in a new format. So listeners can still work. Of course, we need to make sure that our business logic is doing that properly. But if we have those life cycles, then we can, for example, in one deployment, introduce the new event format, give the graceful period for the listeners to stop listening for the old format and the new one. And usually that might be, if we have short living streams, then that means that, for example, next stream or next release, we could even remove those obsolete format, because those objects should not be living anymore, right? So people might just stop to do that. Of course, that's kind of ideal scenario, and that's not always possible, but that's something that I would recommend to go forward. Because, of course, there are techniques. I encourage everyone to read the Versioning in Event Source System by Greg Young. And in general, Greg Young's works, because he's, I think, one of the most, or maybe the most important people in regards of spreading the awareness about event sourcing. And he wrote a book. A book sounds scary, but it's not such a long book. And even if you're not doing event sourcing, then it's still worth checking that. And there are patterns, like I already mentioned, publishing in a payload that has the old and new data, so we can do some tricks on serialization. There are some tools like Avro, etc., that some schema registry that allows us to do some schema evolution automatically or semi-automatically, and we can do some tricks, etc., how to make that work. And it's good to know them, to have them in our toolbox. But still, as I mentioned, the business aspect of event sourcing is really important. So if we just focus, like you said, on the technical aspect, then we might end up in a crowdsourcing, like you said, so project updated, project created and deleted. But those events are meaningless, because we still don't, if we just send the current state, then it's fine if we are doing like a poor man's replication on top of Kafka. But it's not great if we need to know what precisely has happened, because then even if we have this event sourcing and have that events, then we are also losing data with those events, because we don't know what has changed, what triggered this specific change. So, I mean, sometimes we need to do migration, but even in a relational world, each of us been doing migration, and they are never simple. So I won't be lying that, it's not so scary. I mean, if you really need to do the migration, then it will always be some kind of struggle. But it's not so scary as it's pictured in the internet. More or less the same tactics as we are using for regular migration should be applied. Like, for example, if we are adding new column to the database that is required, then we also need to think, can we provide some default? How can we change our code, etc.? The thing here is that typically we should treat events and history as something that is immutable. So if we would like to provide a fix, then we should store and publish new event. So for example, but if we think about that for a moment longer, then that's how business works. It's like you are not amending some old data. If you provided wrong invoice, then you need to send another invoice with the corrected version.
Mm-hmm. And since we talk now about the business and let's say the scary parts, I have one more question about the scary parts, but hopefully it won't be scary. So if we were to somehow combine the event sourcing as well as say as the domain-driven approach when building the code, especially this tactical part in code, so how would you somehow structure your code to make your domain being aware of those events? So would this be, let's say, these regular domain events that would somehow be stored in database, or would this be a different kind of events?
That's a good question, and that's a really important aspect. So I would like to highlight that event sourcing is not an architecture concept. It's not an architecture pattern. We should not apply event sourcing by default to whole architecture. It's perfectly fine to have module like a core domain, the most important domain in event sourcing, and have like a CRUD other service. So event sourcing should be think and applied on the module level. And if we think about the specific module scope, then in that particular scope, events should be as small as possible and as granular, as we said, to not lose the business information. And as we are developing the module, then it's usually the same team, and they can share the understanding and know what are those granular events. And because that's meaningful for this particular business domain and team of developers, business people, etc. But so in that case, those will be like a domain events, focus on what has happened in our business domain. But if we are thinking and building system that has more modules, and that's what we are mostly doing, especially if we are doing microservices, then it's critical to have distinction of the internal and external events. That's quite often named domain events and integration events. There are different names. I'm preferring to call them internal and external. Why? Because for me, that's more explicit. So if we are using event sourcing in our module, then our domain, then events are really granular and bringing business information. But other modules might not care about the granularity, and in fact, they should not care. Like, for example, if we have reservation process, then the rest of modules are probably not interested at all with all the negotiation and changes history. Financial module probably would like to know only when the reservation was confirmed, because they would need to send the pro forma invoice, etc. They don't care about the granular events. So if we expose all the events, all the granular events, and publish them outside, then that's the first step to distributed monolith, which is the worst case that we can have, because all the modules needs to know the internal business logic of the other module. Like, for example, if as a reservation module we ask other modules to listen to all events, then that's a recipe for failure, because then we need to inform them about all the new events that we are adding to the workflow, and if we don't inform them, then they may miss some important information, but it's also bad for us, because if we expose those events, then we should treat it as a public API, and then we are falling again into the trap of versioning and getting the migration issues, because we need to think, and we might not even know who's listening, because anyone can, for example, subscribe to Kafka topic, right? We are losing, after exposing those events, we are losing the control of what people are doing that with it. So in this case, I would always recommend to expose only those events that we need from the internal one, or even don't expose those granular events and always have some mapping layer. And this mapping layer could enrich the events. For example, after getting the reservation confirmed event, that may, for example, just have reservation ID and confirmed status and nothing more, then we could listen for that event inside our module, get the current state and all the information that we would like to publish outside, and then just have different set of events for external systems. So in our module, that would be domain events or internal, as I prefer to call them. And for the other modules, we would be publishing the external one or integration events. And I think that's one of the most important things to know about how to do event sourcing systems, because that's one of the most common failure I've seen. That creates only issues, even tension between teams, because always contract is breaking. So we should, but it's not much different from Web API. We also have that discussion whether we would like to do backend for frontends or we would like to do API first. So we should treat those public events, infrastructure events as a public API and apply the same negotiation rules as for any other public API. And besides that, because I'm afraid that I went a bit not straight to your question, sorry. So I don't think that your code needs to be extremely aware about the event sourcing part, because depending on what's your preference, you might still use entities because you still need to get the current state. And after you got the current state, then the only difference is that you need to store the event as a result. That's the only technical difference and technical impact on the code. And how you apply that? Typically, if you are doing DDD and aggregate, then you should have like an apply method or when method that takes event and applies it to the state of your aggregate. But then all the other rules, like having the public methods and encapsulating business logics, are exactly the same. The only difference is after that, after you get the current state, you need to somehow store the event as a result. And besides that, not much revolution there, I'm afraid.
Well, first I wanted to say that I guess that your off topic with the events was actually needed. And that's for all the people who are listening. Because something is named event is not necessarily needs to be used everywhere and in the same form. And messaging is not an explanation for coupling in any form. So as you mentioned, if there is a situation in which I'm giving you too much information, probably unnecessary, then there is still chance that you'll build some sort of logic on top of it. Then if this payload changes, I'm in this weird situation in which, I need to adjust my code, which is, as you named, the distributed monolith. Don't do it. So it's good that you differentiate those two types of events. So this internal and external or domain integration. But I just wanted to get back to let's say application architecture, because you mentioned that the event sourcing should not be familiarized with the or treated as an architectural approach, which is, to me, sounds reasonable. So could you answer me the question why under my CQRS clean architecture / CQRS video there was just tons of questions about why I covered CQRS but not event sourcing? Why this event sourcing is I would say tightly coupled with the CQRS term?
That's a good question. I could make a joke that that's probably because people are not reading the source documents. But I will get to that later. I mean, for me, CQRS and event sourcing are separate patterns and that are related to each other. However, for me, CQRS is a more general pattern. It's I'm having also my own crusade to explain differentiation of that to people, because from the original work of Greg Young, this document, CQRS documents, a lot of people just took the single image where it shows that you have different databases or different tables, while it's just a part of that document. I'm almost sure that if they read the whole document, that wouldn't be the only conclusion they got. So CQRS, for me at least, it's not about different data models or different storages, etc. It's about segregation of behavior. So for me, you could do even CQRS on the same single table, and that would make sense. Like, for example, because the segregation separation is that if you are reading data, then reading should not cause side effects. So by side effects typically meant changing the state. And comment, the intent of comment is to change the data, not return it. That's the general rule. So nothing about storage here. So what's the storage behind it? You could put probably even Excel spreadsheet and do CQRS on top of it. Storage doesn't matter. And for example, if you, for me, CQRS, it's just a pattern of reducing the cognitive load. So you can focus your effort at first on writing the proper domain logic and how to write data into your preferred storage, and then you can focus on how to read the data that you just stored. So for me, that's the critical part. So not data model, not storage, but segregation of the behavior. And as I mentioned, you could even use ORM, store data in the single table, and for example have database view that would just return subset of data or join that data with other table and do a query, and that would be perfectly fine. You don't need to do event sourcing, different databases, whatever. However, one of the advantages, not the defaults, is that in CQRS you can optimize. So for example, store data in relational database and then somehow transfer information about the changes and replicate those information to another storage. Like for example, have majority of storage and queries, like a direct queries on top of relational database like Postgres, but have optimize your full text search on Elastic. And CQRS, because you are segregating the behavior and slicing your business logic, allows you to do that. And some people think that, and that's also true, that you can, for this replication or integration, you can use business events, because then you know precisely what type of change to apply on the other storage, etc. So that's where event streaming or event sourcing jumps in. And all of those weird diagrams with event buses in the middle, etc., because you need to somehow transfer those information. And so CQRS, for me, it's much more general pattern. It doesn't require event sourcing. And the other relation, I think that event sourcing without CQRS is kind of limited. It's hard. You would need to try hard to do it, to use event sourcing without some kind of splitting responsibility, because typically event stores are focused on the right model. So about storing events and retrieving events. And we already discussed that building the read model from each time reading 20,000 of events and joining that in memory won't be efficient. And for read models, we usually are focused on making that as fast as possible and as most straightforward. So that's why after we stored events, then we are subscribing to those change and apply that to dedicated store. Of course, some event stores like Marten that I mentioned, I'm co-maintainer, is using Postgres, so the same storage for events and for read models, but that's not so common. So my guess is that's where this idea about that you have to use CQRS and event sourcing comes from, especially that, again, Greg Young that invented CQRS is also advocate for event sourcing. So probably a lot of examples that he was doing was showing both. And so for me, CQRS without event sourcing, perfectly fine. You can do event sourcing without CQRS, but then for me, it's like event sourcing and CQRS is like tequila and lemon. They go really well together. So I would recommend to consider using that, because without that it would be harder, but you might try to do that and do it. It's also possible, but typically in event sourcing, you by default, you have this responsibility segregation.
Yeah, I'm really glad that you mentioned those things, because first it means that I don't need to re-record the whole course on YouTube because I had the exactly what you mentioned. So the CQRS was described more on the behavior segregation level, while the database remained the same, and that was just a matter of different types of accessing and the projection level on both writes and on the writes comparing to the write side. But also this, I would say, dependency, which depends on which. I mean, the CQRS itself can be easily implemented, and you also got the blog post about this, about the CQRS itself, and that it's not that complicated as you might probably think. But the other way around, and I believe also that Greg Young on one of his presentations, when he was describing both CQRS and the event sourcing, he actually started from the event sourcing and then jumped into the CQRS, because that was some quote like the CQRS. Now, in our case, because we have the limitations on the efficient reads, now we may think about the CQRS, which basically says that you don't need one system, you just need two, optimize for different things. So it was other way around, and in this narration it actually makes sense. While if you take this out of context, then it's like, okay, so if I'm introducing CQRS, then I need to introduce the event sourcing as well. I fully agree. So I would say that CQRS is about slicing your behavior and application based on the business operations and what they are doing. And event sourcing is more about the storage. But that's also a general issue, because in majority of resources that I also found, it's confused. I mean, it's not intentional, but because, as you said, people doing event sourcing usually are also using CQRS. Then when they are describing their application, then they are so familiar and so accustomed that they are doing both that they don't see that this might be confusing for newbies. And I think that's also one of the reasons why it's so confused. And for me, CQRS, I fully agree with what you said. It's a really simple pattern. If people just focus on this segregation, then I really don't see why it's perceived as complex pattern or requires boilerplate. In fact, in my opinion, it cuts complexity, but that's my perspective.
So it may sound that trying to add the event sourcing might be a bit difficult, because it sounds that for a greenfield project, when you can do anything with application architecture, infrastructure, that should be rather easy to do, let's say. But is it always the case? What if you would like to somehow start introducing the event sourcing into the already existing, maybe even some kind of legacy system? Do you think it's possible, or how difficult could that be?
So I will maybe start with whether this is really indeed easier to introduce in Greenfield because there are two perspectives. Technically, for sure, it's easier because you can design your tool set as you prefer. But on the other hand, if you have legacy system and it's working, and then you have much better domain knowledge usually, which is quite critical, as I said, to making right your event model. So in that regards, for the legacy system, it might be easier to introduce event sourcing because you are more familiar and it would be easier for you to model what's happening in your system. And so there are two perspectives on that. And how to introduce that into legacy system. So there are two things. One is that event sourcing indeed is the best when you have complex business process. It doesn't have to be financial module. Usually it is when you are starting and you see that in internet. But for me, it's mostly when you have more complex business process. So if you can find out the checkpoints in that business process, or if having the business insight even in the future from the things that happened in the past is important for you, that would be one of the things that is important. However, if we try to introduce event sourcing directly to the most complex business domain, then that's probably also a recipe for failure. So I would not recommend to just start directly with the most complex process. I would probably suggest to start with something that is not important. So someone won't kill you if you fail with that. And so something that is probably that is enough complex, like for example, shopping cart. Shopping cart is I know that it's a bloated example, but it's enough simple to understand what's going on, and enough hard to have the justification for all of those recording of the business process, because we can have like a future insights, like see what products were dropped and how long is typically the business process, etc. So we maybe start with something that has at least 2 or 3 steps, best if this is some kind of asynchronous process, and try to refactor that even as a playground. So find something that you could do within few days, like a proof of concept that you could do within few days, not within few weeks. Because if you try with something harder, then each of us, and it's not only about event sourcing, but if we try new paradigm, then we need to learn our own mistakes. When I started my journey with event sourcing, before that I read a lot of books. I watched a lot of talks. But when I started to coding, then I was like this dog on the meme, like I don't know what I'm doing, right? So if someone starts with the core domain, then the risk is that we'll fail. And after we again come with the idea of bringing event sourcing, then we might get a backslash and people will tell, Oskar, how that ended up the last time you wanted to introduce event sourcing. So my recommendation would be to start with something simpler, not like extremely simplistic. So something that has some workflow and some potential to use event sourcing, but simple enough so we could, play with the tools, understand how to use them, and make some basic mistakes, learn from them, and then expand it to the bigger domain. And also important thing is to learn operations stuff about the tools that we are using, because from my experience, I probably shouldn't tell that, but those tools are not so easy to run as operational if you are a newbie. Once you learn it, it's okay, but the ramp up phase may take some time. So I would suggest to start with something small, get it into production, see how that's working, see what issues you found, then make notes on that process and then expand it, not just throwing yourself directly into the ocean.
Yeah, but I wanted to ask about one question, because at the very beginning of our conversation, you mentioned that today the storage is cheap and the information is priceless. And to me, I would say the weird part about refactoring the legacy code and introducing the event sourcing is that, okay, I can introduce the changes within my code base, which now may take the advantage of the event sourcing, but I still do miss one of the most important part, being the information, because I cannot reproduce the events if I haven't stored them from the day zero of my project.
Yep.
I only have the current state. So the question is, would you suggest, or maybe it's still just a matter of some sort of measurement, but once again, when we start the Greenfield project, we might not be even sure whether this information at future will make any sense or not. But do you think that it is a good idea to start doing the event sourcing by default, or maybe even not the full event sourcing, like producing the events, storing them, and then creating the read model, but even just putting them into separated storage just for eventual sake of usage?
From my perspective, I don't see like the clear scenario where event sourcing wouldn't be good choice. I mean, like where it wouldn't work. I see some scenarios when it might be an overhead. If we have like a simple domain or like I call it usually that type of modules, a CRM, so a bag of information that you just put and you want to just get out and that's all, then maybe event sourcing is not useful. And if you are not familiar with event sourcing yet and you are starting journey, then doing event sourcing by default is dangerous. So I would rather suggest to focus on one module. But I think that your idea of storing somewhere those information is also good in some audit log. It doesn't have to be some event store, maybe even in Elasticsearch, so you can search by that, etc. But then there is a risk where a lot of people are falling. That's why I'm not saying that audit log is like a main advantage of event sourcing, because then you may fall easily into the trap, like the mixing event streaming with event sourcing, because you get so familiar that events are just a side effect of your business logic. So they are not the first-class citizens, like in event sourcing, and changing the mindset and the tooling that you already have might also not be so trivial, like, because in theory you could even use Kafka for audit log, because you can set retention policy to infinite and have all of those events there, and somehow that could even work. But what I'm trying to say is that this is a good idea, but only if we just make sure that we understand what are the consequences. Is that it's not a precisely audit log, is not precisely, might not be the same type of data as generated by event sourcing, because you might still have wrong boundaries of the streaming, as we discussed. So that's why people are so quite often want to have a long stream. Like the extreme example is one of our customers have stream with 100 millions of events, and even StoreDB can still handle that, which is surprise for me. But you know, probably they were just familiar, because if you are using messaging or streaming system, then you know they are just pipes. You are just pushing another event and they store it and you subscribe on the other end. So it's fine because you're just going through the append log. Event stores internally are also append logs, but then they have all the structures around splitting those, huge log into the event streams, so representation of our records. So having this audit log is a good step, but might not be enough if we don't think already about the modeling patterns. So it would be still much better to get this data in the future, because we will have them and somehow we can transform them, than if we don't have, we just have the latest state, but it might not be enough. So if we are familiar with that we might need to do another work or some ETL process, then that should be fine and better than nothing. But yeah, we just need to keep in mind that might not be enough.
One question just popped in my mind when you mentioned that this is the append only approach, because from what I understand is like the event store and the all the events that I put in there are like immutable. I cannot change them. At least I should not, probably. So because you already mentioned that the versioning part, in which there are a few techniques in which could be beneficial for us, but what in terms of the situation in which, let's say, the payload that I put into my event is simply wrong. So let's say that I calculated and put the net price instead of gross price. Like very stupid example, but gives you the idea. So basically it's not the matter of the structure of the event, but rather the payload. So assuming that the whole sequence is now, like, I cannot just simply go into database and change the payload. So how can I do such a corrections over the time? Do I need to produce some correction event, or there's some other techniques?
Yeah. So I will give another lame joke. I have a post that type of situation is the same as texting your ex after the party. Like you just wake up and see that you texted your ex and you see, oh God. So depending on the tool you've used, then you can try to erase that. Like some tools like WhatsApp allows you to even remove the information. And some tools like even Kafka allows you to delete the events, but still you are unsure because your ex could already read that information. And so in our technology part, some other service could read that information and run their business logic, and also they might have broken data. So if you are quick enough, then maybe you are lucky, but you don't have, unless you check the other system or, call X and say like, hey, did you get the message from me? No. Okay, then bye. Have a nice day. So that's the same case here. And we could try to update it, like Skype allows you to modify the message. But then again, that's the same story, because some other service won't know that you edited if they already received the message. And for example, if you're using Marten, then technically, as you have this relational database underneath, then you can run migration. I was doing that. I don't recommend that, but that's also some pragmatic way sometimes. For example, if you have a broken data on your test environment and that was not propagated to production and you're sure, then maybe it's not worth just, doing whole orchestration and changes and providing another type of event. Maybe it's better to run migration or just erase the data and start from the beginning. That's some pragmatic choice that you can make. But the best way is just like with X, just send a message with, oh, sorry, I was drunk.
The compensation message.
Yeah, exactly. So the best way is to just send another event with the correction. Of course, it's not ideal, because I think that we didn't discuss one case like the read models. So one of the benefit of event sourcing and having this data is that we can even erase the read models and replay them again. If our data is fine and just we had the issue with the business logic, or we change the interpretation of the data, then we can just run it fine. But unfortunately, if we have wrong event that is causing, for example, some null reference exception or other mistake, then we need to also update our code to be familiar that, you might get the broken event, but after that, you will get probably the correction event. And another story is that also the other modules needs to know about the existence of such correction event. So it's usually good to predict that something wrong may happen and think about that and not assume that we won't make mistakes. And if we don't have this compensating event, then unfortunately that may mean that all the other systems that are listening for that event will need to deploy the change that to be familiar that they need to apply this corrective event. So sometimes it's also think about that in advance and maybe provide like this anti-pattern event with the current state. Like maybe we could, from the operation side of thing, if we see that, we broke something, then just publish such event and the other modules that just need to accept that. Because internally inside the module, we have much more options. Like I said, we could even do migration if our event store allows us to do it. And we are much more flexible on what we can do. But if we are also publishing this event, then that makes a difference. But another case is that's also where this mapping layer is beneficial and not publishing all events, because we are reducing the chance of mistake and we are giving ourselves another tool to use. So do the mapping of the events that we are publishing from our module.
And where do you think all these typical mistakes come from, and what do you think are the most typical ones? Because you've just talked about a few, and it sounds like these mistakes would be some kind of implication of developers maybe misunderstanding their domain, maybe missing some events or some payload. Do you think that's the most typical case, or are there more mistakes?
I think that mostly it's about humans. We just are not machines and we are making mistakes. That's nature. So I think that the critical part, especially in the distributed systems, is that to understand that probably there won't be even 1 second when all the components of our system will be working fine. There will be always some malfunctioning component. That might be technical issue, or usually for those most severe bugs are like our own mistakes. And I think that's fine to make mistakes, but we just need to accept that and think about that upfront. So don't assume that we won't be doing mistakes, or bugs in code will always happen. The only case where you are not making mistakes, and if you are not adding new code, that's the only chance to not make mistakes. But to be more precise, inside the module, usually I think that it's the more we talk with each other, the more we talk with business people, the less likely we will have those issues. So again, the business domain understanding is critical. And because from my experience, business process is not changing so rapidly. Usually it's like you don't have like a business process changing every day or every week usually, but our understanding of the business process might be changing every day or every week. So that's one of the things that can cause the issues. And I think that we as developers are quite, we are like to say that business people won't tell us how we need to write the code, and we are sometimes thinking that we know better than them how to run the business. So we need to be more humble. That's my recommendation. And for the general issue, the biggest issue that I see is unfortunately the Conway's law. So I think that's the most common issue. And those are really related stuff to what I told. Like if you expose all the events and expect all others to consume it, then that's a potential issue for conflicts. Like, because then people will be complaining that, why didn't you tell me that you changed this event? Or why didn't you tell me that there is new event that I should listen? Or they will be complaining that, yeah, that team sucks, they never told us, etc., etc. So unfortunately, I think that the organization, the company culture is quite critical. But on the other hand, I think that events can also help on that, because business are easier to understand from the business perspective, but also from the technical perspective. So I already mentioned that we should talk to domain experts, but also if we start to think about events as a public API and some kind of contract that should be negotiated between teams, then that also can facilitate the need of discussion, and maybe can encourage teams to talk with each other and not just hide in their own castles and just, send emails, etc. But of course, that requires thinking about events as some common contract. And I think that once we have it, and we have, things like contract testing, we are making sure that we are not, at least trying to not make breaking changes, and we are just careful on just like a development culture, then it would be much easier. But on the other hand, I don't think that this is like a really specific about event sourcing, but in general, I think that if you are using event-driven architecture in general, then you will be facing those issues earlier. You will have more or less the same amount of issues that you had typically, but in the classical architecture, you might take a loan and get those issues later. So maybe that's the difference. I'm not sure if that answers your question.
Yes, totally.
Yeah, and actually, I think that it's safe to say now that in the next episode of this podcast, we'll actually cover few things that you also mentioned, especially regarding Conway's law and its implication on the way that we will design the distributed systems and how this may basically impact this. So I think that this will be kind of good bridge between those two topics. But I just wanted to ask you a question regarding the technical part, or maybe the tooling part of this, because of course not we, but you actually discussed the whole mechanism behind event sourcing, how this works, what is the difference between this typical approach with the current state. So I guess that for many people this will be like convincing. Okay, let's do this. Let's try. Maybe not, as you mentioned, not doing this fully into my core domain, but finding maybe supporting domain in which this could actually be helpful. So I wanted to ask you about for the .NET developers, but maybe if you could do this also in more general way, the typical tools, because you already mentioned few like the Event Store DB. You also mentioned Marten, because you are the man, I would say, who's in charge of this project. So if you could say a few words about each of those projects and what offers each of them. I mean, the capabilities, whether this is only about the persisting, also some optimizations, tooling, etc.
So just disclaimer for Marten, Jeremy D. Miller is head. I'm really active there, and I'm co-maintainer, but yeah, it's his child. I'm just a close uncle. So maybe let's start with Marten. And so in general, the event stores, I would say, that are splitting for two types of storage. One is the relational, which is closer bridge to classical use case, because quite often using some natively built databases may be a breaking and a barrier for some organizations. And especially ops teams are quite familiar with how to handle relational databases, so stuff like migration, operability, etc. So quite often, even people would like to use like even store DB, which is natively built, but it's like a database that it's just, don't have any type of other backing storage. It's just a database. Then for them, pushing that in their organization, it might be hard. So using tools like Marten or SQL streams or Exxon that has also in Java land the relational storage can be helpful. So that's one thing. But from the functionality perspective, then Marten for sure I think it's quite unique in a sense that I think that's the only store I know that allows you to update read models within the same transaction as you are appending event. So if you are appending event, then the unit of work and transaction is open, and all the projections, so changes to the read models, may be applied on the same transaction. So you can have a strong guarantee also on the read model updates. So that's quite unusual. Of course, in a high load, that's not something that you would like to do. And Marten also allows the asynchronous projection updates. But besides that, I think that the common ground for all for event store is that, like I said, they usually guarantee strong consistency on appends, and all the event stores I know are doing that. So all that I mentioned, they also allow to read the events and do it effectively. Then there is a difference on the type of data that you can store. Marten allows you to store in JSON only, and even StoreDB allows you to use JSON and also your own binary format, so like a protobuf, etc. So having binary data for sure gives more possibilities for storage optimization, for even using tools like Avro, etc. So for schema migration, or having more precise storage of the types, because as we know, JSON is far from ideal, like for the numeric and date times, etc. So I think that the killer feature for Marten is that it's have the read model part also within the same framework, but it's still a framework. So it's like it's tight relation between Postgres and the .NET, and it's on. So you can only use that in .NET and with Postgres. So if you'd like to use MS SQL, like if you're .NET, then you might consider SQL Stream Store. But then I'm not a specialist for that. So if one of the maintainers is listening for that and I said something wrongly, then sorry. But I know that they don't have, for example, this updates in the same transaction, because they believe that it's wrong approach and you should not expect to have that strong guarantees on read model updates, which you might agree or not. And even StoreDB, as I mentioned, is different because it's natively built for storing data as events, which gives another possibilities for improvements. Because, relational databases are great, but they are like a tomato soup. So they are good enough for most of the cases, but they are not optimized for specific needs. They need to handle random updates, random reads, etc. You can, of course, optimize that by proper indexing, etc. But still, database needs to consider that they don't know your behavior of your application. So if you are using something that is natively built, then you can optimize the storage. Like even StoreDB keeps all the events within the same physical place. So if you are reading, then it scales really well with the number of streams. so if you add more streams, then it won't impact immediately your performance, etc. Because it's designed to have like a the same performance no matter how many streams you have. Of course, it may slow down if you have extremely long streams. But as I said, I was surprised that even 160 millions of events within one stream was handled. And even StoreDB also have the clustering, so fault tolerancy. Marten don't have that part. So if you'd like to have fault tolerancy and resiliency, then even StoreDB has that natively. And one thing that is important for even StoreDB is that it won't go away because it has paid employees like me. Maybe not because I'm working there, but because of the engineering team that, it's quite important if you are enterprise that you can buy support, that you are sure that it's not just run by the bunch of cool dudes that are doing that for their hobby, but just because they are paid for that, right? And you might set expectation on the SLA, etc. So that's really important. The other tool I know that has also backing money is, I think, Axon, which is mostly Java-based. And even StoreDB has the benefit that we are supporting right now .NET, .NET, Java, Node.js, Go, and Rust clients. So it's not on. It came from the .NET community, but right now there are clients, gRPC clients built on top of that, official one, but also some community like the Ruby unofficial client, Python, etc. So I would say again, for Marten, the biggest benefit is that you can have this read model in the same place, but then you're limited to .NET. And for even StoreDB, like the clustering, the resiliency, fault tolerancy, scaling, and we also have our own cloud. So that's also quite important because you might offload operation side of thing to us. So you can buy managed service, and that will be run on one of the most popular clouds like Google, Azure, or AWS, and we will be handling that for you. So that's also benefit, I think. Some clients appreciate that.
Okay. I also wanted to ask you about one more thing, because after working for this many years with event sourcing as both the developer and the advocate now, do you still sometimes encounter some issues that you have never seen before, never heard about, something like new that really strikes you and, I need to think how to solve this?
To paraphrase this, if you could distinguish this between the human errors that you mentioned, so most stupid things, or most, I would say maybe not stupid, but inefficient things that you've seen regarding the event sourcing, or maybe also the limitation of the platform software itself. I don't know whether it is like the features in Event StoreDB or Marten are driven by the issues that you encounter on your daily basis.
So for sure, like maybe not every day, but every week, I'm quite surprised on what people can do with those tools, to say mildly. So just one suggestion, if you want to maintain the OSS project, then just hide everything you can from the public API. Because if you expose it publicly, then people will try to find another weird things to do with that. To maybe give some precise example. So for sure, for Event StoreDB, and if you're Event StoreDB user or would like to be, then listen to that and don't do that. So quite often is the opposite way of Kafka issue. So people are using Event StoreDB as queue. And Event StoreDB, as I mentioned, can handle a lot of streams, long streams, but for sure it's not built for that. So if you are putting a lot of events within the single stream, then the pressure on the database will be really high. Especially Event Store also provides transformations that you can do on the fly with events. And people are, trying to use that for read models, even because you can read from the streams. Like you can, for example, transform the upcoming events and put that as a, for example, current state as another event on the stream, and just trying to build the read model side of that. Also, for example, ignoring the limitations of some features. For example, in event sourcing, we have two types of subscriptions. One is catch-up subscription, which is like a sequential subscription, so you can get even one after another. And we have a thing that is called persistent subscriptions. And persistent subscriptions should be, and it was named some time ago as a competing consumers, and it works more or less like RabbitMQ. So you already, I think in the last week, presented some stuff around Rabbit. And yeah, if you expect to have ordering guarantee on top of competing consumers, so multiple listeners just taking one event after another, then that's not gonna happen. From time to time, you will get off the beats event, and that can cause issues for the read models, rebuilds, etc. But people are using that because for catch-up subscriptions, you need to handle checkpointing on your own. And that's intentional because you would like to, for example, store checkpoint with the same transaction as handling events to know what was the last event you processed, to have, for example, exactly one semantics. But and that's the reason. And I think that we have that even described in the documentation, even like a big warning that persistent subscription don't have the full guarantee of ordering, but people are still surprised by that. So probably as a dev advocate, we should continue to do that more often, maybe bigger warning or more red or some animation. But yeah, and that, as we discussed with Kafka, that might have some serious consequences, right? And quite often also people are asking, even today we had discussion in the morning, that people are asking how to mock the event store or Marten clients. And the answer is don't. So, people are just, because event stores are the specific set of databases. And of course, the logic might not sound so complex, but because it has some specifics that you might not be aware, then trying to mock those clients might get you into the troubles, because you might be facing some edge case that you didn't understand, and the behavior might be much more different than you would expect. So there is no point of mocking that. You can put some wrapper around it to better write some unit tests of your domain code or application layer. But if you want to do tests, then just do integration tests. Nowadays, spinning up the Docker image, like both Postgres and even StoreDB images, are quite lightweight and they are quite quickly to respond. So yeah, that's something that I would really discourage trying to mock that. Like in Marten, our iDocument session interface, which is like a DB context for for entity framework, is such a big one that at least that discourages people from mocking that, because they would need to mock like probably hundreds of methods. So that's, and then you might be surprised, because all tests are green, you have 100% coverage, and then you are getting into production and the basic case start to fail because you didn't test on the storage. So in general, even for relational databases, mocking and not doing, and just believing that you can mock and figure out all of the issues that you might be facing is, for me, it's a no-go. So I think that those are the most common thing, and of course those long streams, but that comes probably from those issues that we discussed. So maybe some literature or blog articles or familiarity with the queuing and streaming platforms, and people believe that it's fine to just put next events. And I also had a series of blogs like about state obsession, which is like a crowdsourcing, so not having granular events, or or property sourcing even. That's also some common anti-pattern that you make so your event so granular that it only contains like a first name changed. Yeah. So yeah, it's usually, I would say that mostly it's around understanding how the tooling works and the modeling patterns, just trying to project your past experience on the totally different type of storage. But I don't think that this is strictly special for event sourcing. I saw similar stuff people doing for DynamoDB or Cosmos DB, so expecting that they will just work as a regular relational databases.
Yeah, this is, I guess, that we discussed this before the actual recording, that it is also very crucial. This is what you try to do on your blog, is to explain the concepts and focus on that, because I guess that with the deeper understanding of the concept, then the usage of the either this or that technology in general is way easier. And if I know to which particular operation I should use a hammer and how it works, it's way easier to just pick up the right scenario in which the hammer is a good tool, because maybe not in every single aspect it should be used. So I guess that this is all about the education and not falling into those traps of all the buzzwords and technologies, which of course are in many cases, at least to me, they are useful, but we need to we need to understand that technologies, may come and go. The concepts remain the same, basically.
Yeah. I'm also always saying that properly written CRUD is much better than badly written event source system. So, if something is working, then why to break it? I mean, I would encourage anyone to play with event sourcing, but I'm not trying to sell it as a silver bullet, because it's not. It's just a tool that may enable you to do things better or in a more optimized way or whatever. So I always encouraging people to just try new things and play with it, and then you might realize that actually that might work for me. So I see, for me personally, event sourcing is a pattern that allows me to deliver applications that are closer to business, because I like to code, but I just don't like to code just for the sake of coding. I like to do something that is meaningful, that people are using. So and so far, in general, event-driven architecture and event sourcing are patterns that for me are the closest to that one, to making that happen. But for sure, they are not the only paths that you can take.
Yeah, and I'm glad that you said that. I'm glad that as an advocate for the event store DB, you're not like here. So here's why you need to apply the event sourcing in every single app. Hopefully, you'll not get a call after this podcast like, dude, you were not supposed to do that. But
I forgot that I have to say 20 times use event store DB, but maybe at the end.
Yeah, we'll give you. I will add the jingle. You will have the 20 seconds for this, so no issue. We'll add this in the post production. It's not a big deal. The last question I've got for you, because I just wanted to ask this question, and I would really like to get your honest opinion on that, because honestly, through all my career, I was developing only one event source system. And maybe this is just a matter of the friends or the type of community that I'm currently within. But I personally feel like event sourcing is still like a niche, or at least we can consider this as a niche, because of course, when you type the event sourcing, either on Google or YouTube, there's quite a few materials, presentations, etc. but on reality, I mean, it's more likely that you will find out the microservices on your daily basis, or mentioned RabbitMQ, Kafka, rather than the event store DB or Marten. Mm-hmm. So do you consider event sourcing still as a niche, and why is that? Is it because of the cognitive load, the misconception of what this pattern is actually all about?
Yeah, I think that it's still a niche. I mean, different people say that differently. For example, I was quite surprised to see that InfoQ put event sourcing in their adoption pattern as already a commodity. I'm not so optimistic, and even internally in Event Store DB, I think majority of people I discussed that told that, yeah, that's probably too early and too optimistic. But I think that this is something that will grow. And it's already mature, because like if we have a look on those talks, and when they were posted, then they were probably posted like over 5 years ago, because then event sourcing was a hot topic. Like Event Store DB exists for 10 years, Marten I believe for 5 years, so they are already a mature project, and a lot of big companies are using that, even from top 50 of Forbes. So it's not like it's still a toy. But from my perspective, each technology, when it's going through its lifetime, needs to go through like a collapse phase. So by collapse, I mean that there is a hype phase at the beginning, and a lot of people are trying to use those tools and just put in their greenfield projects, and then they realize that they failed. And the case of failures are for sure mixed. For sure, those tooling at the beginning in the hype phase are not yet mature. For sure, they are not already distinguished patterns. So like we discussed today. And people are, just building, just flying on the plane that they are building in the meantime. So that's obvious that a lot of people are just failing if they are trying those tools in a hype step. And after that, there is a lot of blog articles like why this is not working, or why this sucks, or not use that one, or why I left something, right? It's not only about event sourcing, but in event sourcing, we already had such set of articles. And also it can be visible that there is also presentations that were showing not only the positives, so the light side of event sourcing, but also the dark side. And for me personally, when I see that those articles are happening, means that the technology is becoming more mature. Because if there was no articles like that, then it means that probably no one really used that technology. And even if they used and failed and there are no articles, then means that people didn't care about that part, right? So it was like, okay, that just sucked. Let's move on. But if people, getting their emotional thingy into that, then it means that it's something. And we already discussed some patterns that were found out after this hype phase. So there is still already some mature patterns, and technologies are, in my opinion, quite mature. Not in all aspects. Like I mentioned, ops part can be and should be improved, but it's happening. So currently, I think that it's still a niche because it's still kind of the practitioners and the people that are now event sourcing a lot are not so keen on sharing their knowledge, or sometimes they can't. So there is not a lot of case studies like the success stories around that, and cases like, see, this is how we did that. You can do it that way, and if you have similar case, then this will probably work also for you. I tried some time ago to gather like those success stories, and surprisingly, I got a lot of positive feedback. So I expect to have less interaction with people, but a lot of people reached to me. But they said that, yeah, I will tell you, so you know how we use event sourcing and how we are using that, but you cannot use it because my company thinks about event sourcing as a competitive advantage. So they believe that because they are using event sourcing, then it makes them better than the competition. And that might be true in some cases because, they have more data, more things to analyze, more closer to business, etc. So all the advantage that we discussed. But in my opinion, that has to change. So we need to really be more open, and especially event sourcing came directly from the DDD community, and DDD community is fine. But the typical answer from the DDD community is it depends, or or focusing on the 5% or 10% edge cases. So, it's great to discuss all of the shades of grades and what you might be found. But if you are a newbie, then you search for recipe. Like if I do it that way, then maybe I won't succeed in 100%, but I won't harm myself badly, right? So that's what some people expect. So I think that this is happening. So, that's probably why I was hired in Event Store DB, to just explain that to people and teach them that event sourcing might help them, and that they should consider, or explain also those anti-patterns. So I still believe that we need to do better as a community. So share better knowledge, show more practical aspects, like the specific bits of code. Because, for example, DDD community is focused on the design, not on the implementation. And as I mentioned, I read a lot of DDD books before starting event sourcing, but then I have no idea how to implement that. So we need to be better at samples, about materials, and that will spread. Because the common case I see right now is that people start using streaming platforms, and they were having this messaging system, and that was fine for them. And I think that's a good start, to start with the event-driven and messaging, and then go into event sourcing. But then they have those cases that you said, Darek. So they are realizing that, we are publishing all of those events. It would be such a great thing if we had them stored somewhere, because right now we have the feature, and if we had all of those information, then that would give us a lot of money, right? And they are coming and trying to ask us, we were using Kafka, but we realized that we would like to have those data, not only to put it from one place to another. And that's more and more people are coming like that. So I personally believe that it will be spreading. But yeah, it's still a niche. It's still a niche. I really believe that it will expand, but I'm not sure if that will be ever like a commodity, like a real commodity, like a relational databases. Maybe, but I don't know.
Mm-hmm. So to all our listeners, let's open up, okay? If you've ever worked with event sourcing, or maybe you're considering, if you have any questions or any histories to share, just feel free to write comments, or maybe your blog posts, because it seems we need more of that stuff to share it.
Yeah, and if you have never worked with the event sourcing and in general event-driven systems, then you can just visit Oskar's blog, so event-driven.io, and you can just use the share button, and you can just put this onto any social media, so the people will actually get know those topics, and will also see the concepts, the issues, and a few other stuff that we discussed today during this talk. So I think that at this point there is nothing more. I just wanted to say thank you, Oskar, for a great conversation. It was just a pleasure, and
thank you much.
I mean, it's just safe to say at this point that after almost 2 hours of you talking about this without any issues, you are an expert in this topic. That's for sure, and I also personally noticed few things that opened my mind a little bit. So hopefully after this episode you will know the basics of the event sourcing, the typical issues. And you also know that you should definitely not call your ex while being drunk. So our podcast entertains and educates at the same time. And of course, as usual, all the materials regarding the Oskar's blog, also other links to mentioned Marten, EVStoreDB, the Greg's Young book, I will just put into the description, so you will have an easy access for those things. So once again, thank you very much, Oskar, for the conversation and for being our guest.
Yeah, thank you. It was also a pleasure for me, especially that I see a lot of alignment in what you're doing, in your the way how you are explaining things on your YouTube and other places. So I'm really happy that we have the chance to talk and to record that discussion. So, and I hope that it will help some people to better understand those concepts.
Thanks. Yeah, and hopefully see you at some conference maybe this year, stationary. Finally.
Yeah, hopefully.
Right, so thank you once again, and the Software as We Know It will return within 2 weeks. Thank you.
Thank you.